So we're going to go ahead and get started with the first talk, and I'd welcome Dr. Tai to the podium.
Okay, so I control that there. All right. So thank you for the introduction. So the talk today now changed the tone a little bit. We've been hearing how powerful AI is in the integrated diagnostics. Then now I'm going to talk about the ethical AI, the importance of it, and the challenges to achieve the goal by the design of AI. So the key point I try to say here that the AI model that being used in diagnostics is become much more complicated now. You can see that you use the deep learning model and multi-model learning as well. That this morning you've been hearing some key point. So because of that, the machine learning model is moved from traditional statistics to a deep learning model. And when the model gets deeper and deeper, it's have higher accuracy, but it's harder to understand. So most of the talk today, when you apply AI, you don't know exactly how it works, right? It just magically make a good decision. So as you see the chart here, when the model gets deeper, then the interpretability also get lag, right? So the question here is that how we're able to understand how AI works, and is there any shortcut learning? Yeah, is there any shortcut learning formed by that? So we all know that one very simple example, we know the ChatNext model, the 121 layers model, they create shortcut by not looking at the image of the lung, but it's look at the token of the lungs for the prediction, right? So everybody know that famous example. And also, another problem in AI for training here is that it creates the bias. Right, so we collect data and annotate it by human beings. So the human bias encrypted in there. Then it's encoded in the model when it's training, and during the training, it will amplify the bias, and then the output has the bias in there. And in some cases, the output data become the training data for the next model. So the bias encrypted and circled. So how we're able to minimize that bias. Another problem in machine learning when we design is the privacy and security. So machine learning works in two phases. We all know training and inference. So during training, there's another attack vector called poisoning. They can poison the data in order to make the model doesn't work correctly. But in the inference, when you deploy the model, it even creates more attacking vector. So you see here, membership inference attack. What does this mean? It means that you just deploy the data. You never deploy your training data. You just deploy the model. They attack the model, reverse engineering to predict the training data. So the privacy is gone at that point. Or they also attack the output through the model extraction, or even the adversarial example here at the input. You see some famous example when you have the input with a little bit of noise in there. Human being, you don't see the noise, but it makes the model misclassified right away. So that is the adversarial example problem. So we have privacy, security issue as well. So that comes with the ethical AI. So there's this area we need to take care of that ethical AI. First of all, the model must be understandable to all, which is transparency. How we obtain the transparency with I'm going to talk later about explainable AI for that one. Secondly, it must not discriminate against anyone, right? So that's the inclusion. Responsibility, nowadays, when you deploy the AI, no one really takes responsibility for that. So must be someone who takes responsibility for what a machine does. I've been hearing ChatGPT a couple of times today. ChatGPT says, here, this is ChatGPT, no responsible, right? They have a legal binding right beginning when you use. But in the clinical setting, you cannot say that from the machine learning predict you have cancer, for example. You cannot say, I don't take responsible for that. There must be someone take responsible for what the machine does. And impartiality must not follow or create bias. And so the bias reason I talked earlier, reliability, the model should be trustworthy, reliable, generalizable, because when we tested only 2,000, for example, data, then we deploy the model into different data distribution, generalized or not, it may be good prediction or not, we need to be able to verify and prove that, right? And also, again, have to be secure and protect the privacy, as I just mentioned. So that's what comes with the ethical AI. So this clearly is not one person work, right? It's multidisciplinary and interdisciplinary, not just computer science. It should be the domain expertise, the law, and sociology, and social sciences, and humanity as well to define all this concept. But here I'm going to talk about what we're going to tackle this ethical AI from a computer scientist. So for us, we call algo ethical. When we design the machine learning algorithm, we focus on 3 areas: security, privacy, explainable AI, and fairness. So these 3 try to address the 6 areas I mentioned earlier. So when we talk about security, privacy, of course we protect the security, privacy area. We try to guarantee the reliability. When we do explainable AI, we try to do what? Try to make sure the transparency of the model, because we explain why the model makes a prediction. So that is the transparency. And also, when we use explainable AI, we're able to figure out if any fairness encoded in there or not, as well, or any inclusion problem, and then the fairness. So, but all these 3 points I'm talking here is interconnected to each other. It's not like we address these 3 points separately. So for example, security and privacy, we have a couple work along this direction. So if you're talking only security and privacy, we don't care about explainable AI, we don't care about fairness, just security and privacy. It's only very challenging because we have to make sure you're able to protect the data privacy, right? During training data, we have to make sure that the model robust with the adversarial attack. We have to make sure that we're able to prove, mathematical proof that it's robustness. So when we connect these 3 dots, the final goal, the model you design, it still have to be high accuracy. The model utility has to be high, right? You don't want to maintain all these 3, but the model precision low, no one going to use that model. So we designed a couple model here, a couple paper that I list here that are able to try to protect this one. And with the explainable AI, so explainable AI here that we try to explain what feature that machine learning look in order to make the decision, right? But when we explain, doing explainable AI, we have to take care of security, privacy as well, because people may attack your explainable AI, right, to do a wrong explanation, or exploit your explanation to do something else. So it's open a new attacking vector, let alone the attacking vector that I just talked earlier. And also, when you talk about the security, privacy, you also need to protect the explanation as well. So it goes by direction. Likewise, for fairness and security privacy, it's not just fairness alone. What does mean fairness? You try to minimize the risk of expose some sensitive information, for example, gender, age, race. Then at the same time, you may create different problems, right? So we try to address all that together with connect the fairness, utility, privacy, training, and robustness. So I just want to say to you that in order to design the algorithm taking care of ethical AI, we have to design several different things. So let me talk a little bit more explainable AI to see what we have so far, because we've been talking about interpretability a lot. So when we talk about explainable AI, what to explain, how to verify, and what if the explanation been exploited, how to protect. So we have to address all this together. So here's some examples that we done in our lab. So first of all, you just simply, the very basic step of explanation is that here, the machine learning look at this feature and make that decision, simple like that, right? Now we go beyond that. Feature is not independent. We need to say that this group of features appear together, that it means accuracy, right? So then we have to show the correlation between the feature using the PGM model. And now look at a feature is not enough. We have to look deep into each neutron layer to see which neutron is important and critical to the machine learning prediction. So for example, I just said the ChapNet model. when we use this explanation, look deep into each crystal neutron, we notice that the model, as you see, the red color is the important part of the image. And you can see that the low level here, the unreliable prediction, they look at the board of the image, they don't look at the log. So that the shortcut learning was trained. And also when the model explanation get exploited, for example here, the adversary sit there, query explanation to understand how the model works. And from there, they can grab the backdoor attack, for example. So how we do explanation without giving too much information to the adversary, but still give a good explanation to the user who want to hear the explanation. See, so that's what we also develop in our lab as well. So you can see that there are many more that we need to address and discuss. So let's just talk more when we do the discussion. And that's all for my talk. And thank you for the NSF for the two funding on this project.